Hello, welcome to ME 510, Economics and Policy of Engineered Energy Systems. This presentation is part one of a two-part module on the economics of oil extraction and production. The material in this module is derived from various sources, including online and our energy economics textbook. The first resource I would like you to read through is a timeline titled The Oil Dependence and U.S. Foreign Policy. This timeline is available at the link shown here, and it goes through U.S. foreign policy. The assignments and quizzes for this week will require you to answer questions about the oil dependence and U.S. foreign policy timeline, so I encourage you to read through those as you can. Let's talk about the oil life cycle. So the way Bhattacharya, the author of our energy economics textbook, describes the oil life cycle is through the steps shown here. A lot of money is spent by oil companies doing exploration in order to find increasingly harder to reach oil wells. Once locations have been found, you can move on to extraction, and so you build the oil wells, extract the oil. You can store it locally or at a nearby depot. Eventually, the oil is transported to a refinery where it's processed and refined. Once it's refined, it's converted into a final marketable commodity, and that final marketable commodity is distributed to end users. Sometimes the products are refined to a quality that can be distributed directly to end users, and so you see that alternative pathway at the bottom right. So let's talk a little bit about exploration. If you really want to hear about how big of a business exploration is, I will encourage you to read this blog article in NPR. But to give you a sense of the magnitude of what's required now for exploration, here you have one of the largest vessels ever built to explore for, like I said, increasingly difficult to reach oil locations around the world. This is certainly something that as we continue to run out of easy to find oil resources, oil companies will find themselves in more and more need to invest into technology that helps them find, gather, and exploit oil wells. Now, in order to reduce these massive costs that go into building some of these exploration vessels, some new techniques and technologies have been developed. So for example, surface geographical studies using aerial or satellite photography. There's some geophysical exploration using physical indicators such as gravitational and magnetic forces. I have a link here that describes how some of this works, and I encourage you to watch the video. However, exploratory drilling is the definitive approach to finding existing deposits. Until you are able to tap into those deposits and try to quantify how much oil is available there, you can never be 100% sure that that well will be commercially viable. And when you look at exploratory wells, there are typically different kinds of wells that you can find, and the industry has developed some names for these. A wildcat shown at the left is one that you can reach after going through the surface. You can think of the area here as like an ocean. And so if you drop your well far enough, you can reach a deposit here that's on top of some rocks and fairly easy to gather. On the other hand, you can have a new pool wildcat, which is a little bit further down the surface. You have to drill through, again, earth. When you have, sometimes when you reach the deposit, you may have like a development test that allows you to extract from there, but that oil deposit may be on the surface or on top of a much deeper pool, and so you can have a deeper pool test in order to try to get access to that. Finally, you can have some oil deposits that are found on the margins or ends of rock formations in the water. Now, when you look at the typical trend or typical timeline to finding a well, in the best case scenario, if you had 100% forecasting efficiency, you would start from zero and shoot right up to discovering all the possible oil deposits. If you did random drilling around the world, you would have a semi-linear probability of discovering all the wells. What most companies try to do, oil companies, exploration companies try to do, is to develop a sort of exploration program that allows them to do better than random drilling. But this is not always the case. And so, in sometimes, especially at the beginning, it's fairly easy to do better than random drilling because most of the wells have not been discovered. But as you discover more wells, eventually all exploration programs start approaching the same probability as random drilling. Obviously, in the worst case scenario, you could spend a lot of time building exploration wells and not finding real deposits. And maybe towards the end, you would be able to reach 100% discovery. Um, this activity can be described by a simple formula. And what this formula here shows is the cumulative measured reserves. And as you can imagine, in the beginning, you can find and measure much reserves at a much faster rate. But as you approach the total discoverable resources, the rate of discovery decreases. And uh, this equation tries to relate that experience. One particular importance in terms of looking for wells is that you have to think about what is the expected monetary value. That's what's going to determine whether you make a profit out of that well. And that expected monetary value is going to be a function of the probability of success times the net present value of the amount of oil you might find minus the expenses it will take to find, gather, and deliver that product. Section 7 of the textbook goes into more detail as to how to calculate different parameters in this equation. But what really matters to us is that is not just the size of the deposit that matters. If it's going to be really difficult to find, and you can try to guess how difficult that would be by using some of the exploratory methods that we talked about earlier, that can significantly lower your expected monetary value. And so sometimes you might pick to develop wells where there's less oil, but you have a higher probability of success. And that's what this graphic is trying to show. So if you're trying to decide where to drill, there might be some wells that have only a small 25% chance of success, as shown here, or others that have a high probability of failure, 75%. And so when you look at that probability and you distribute it to the different wells that you might find, you can calculate the net present value based on what amount of oil you expect to find from those wells. And using the equation that we had earlier, you can calculate your expected monetary value. And so you will find that even in wells that may have a significant amount of resources, because of the success probability, they may not necessarily be um, the most attractive in terms of drilling. In this case, the one with the lower probability here, 25%, but with the highest net present value, does appear to generate the highest expected monetary value. There are many risks in exploration projects. The textbook talks about these in more detail. A couple ones that I want to highlight here. Contractual risk. This is the idea that states typically provide rules governing allocation of risk and rewards of exploration. If you're an oil company and you're trying to get oil from a particular nation because it's a sovereign good, the nation will impose how much, when, and how you can extract that oil. And at any point in time, a nation may say that they no longer want to honor that contract. And so that brings in some contractual risk that have to be negotiated. But there are also commercial risk, and this is when the market itself, its uncertainty can pose a challenge in terms of forecasting how much you're going to make out of a particular project. So these two are mentioned here separately, but as you can imagine, both of these have to be considered simultaneously when starting a new oil project. I want to talk a little bit more about commercial risk that is not mentioned in the textbook. This is an area that I work in as part of my research. And this situation is one that unfortunately happens very commonly. What you're seeing in this graph or in this picture is the evolution of Shell's gas to liquid technology. In 1973, Shell was mostly on the laboratory phase, developing technology to convert gas into hydrocarbon fuels. By 1983, they had built a pilot plant, so roughly 10 years. And you can see by another 10 years after that, they were already building what will be considered a commercial scale gas to liquids plant. And once they had demonstrated this at the commercial scale, they decided to build what we're calling here a world scale plant. So that's the Shell Qatar gas to liquid plant that processes 140,000 barrels per day of natural gas. Now, a cautionary tale about this project is that Shell originally estimated that building this facility would cost only $5 billion. And they had a very nice agreement with the local government that allowed them to get the natural gas essentially for free if they were willing to build a facility. Unfortunately for Shell, they had some unforeseen cost overruns. And what that meant is that by the end of the project, instead of being a $5 billion project, it ended up being about or more than $24 billion to construct and operate. However, because they were able to get access to natural gas at such a low cost, I believe that the plant is still scheduled to be profitable in the long run. But this just shows some of the commercial risk that goes into building these facilities. And because of how long it took to build the facilities, just imagine what the fluctuations in natural gas prices could have affected the viability of the project as well. So what are some issues related to contractual risk? Well, if you have a lease, for example, this is one way to write the contract. You get exclusive rights to explore and exploit resources in an area, and you pay a fee to the country. And there are some regulations that limit what you might do to that area, for example, in terms of protecting human ecological services. But in principle, it's your land for that purpose and during the time that it's conceded. Another alternative, and like I said, this is used in the US, an alternative would be to have a concession. And what that means is that you get a nominal rent, you get bonus payments and royalty payments to governments, depending on how much oil is discovered and how much profit you make. This type of arrangement is attractive to governments and somewhat to companies because it essentially keeps you from paying too much if it turns out that the resource is not as productive as you would expect. And it allows the government to get a little bit more income if it does turn out to be a major project. The final type of agreement here is production sharing, and that is that companies recover costs and shares profits with the host in an agreed rate. In this type of agreement, the oil company may provide service contracts so that they provide services for a fee. So this is the kind of agreement you have if, for example, the host country decides that they want to own the machinery and all the equipment to extract the oil. And in that case, the oil companies play more of a service role to those countries.